All right, for problem 3, it says consider the rotation field F, which is the cross product of the vector A with the position vector R. So in this case, A is the vector 1, 0, 1. And we cross that with the position vector x, y, z, we get negative y, comma, x minus z, comma, y. And as we saw in section 15.5, this vector field F describes rotation about this axis determined by this vector A. And if we look from the head towards the tail of the vector A, we'll see that that rotation is in a counterclockwise fashion. And now our job is to compute the flux of this vector field over any oriented closed surface S in R3. All right, well, by the divergence theorem, the flux is equal to, right, the triple integral of the divergence of our vector field over the interior of our surface S. And this vector field is source free, right? This is something that we saw in section 15.5. And so this triple integral then is 0. So we're saying that if I have any oriented closed surface S in R3, and I think about this vector field to say describing the flow of some fluid moving throughout space, we're saying that the net flow, so in and out of our surface across that boundary, is going to be 0. And that's because we're seeing this rotation about an axis. So there can be fluid coming in, but because of this rotational effect, we're going to see the same amount exiting. And so we get a net flow rate there of 0. All right, well, that's going to do it for this problem. Thanks so much.